Items softened with plasticizers have become an essential part of our modern society. Compound S, shown below, is commonly known as phthalic acid. Esters of phthalic acid are called phthalates and are used as plasticizers to soften polymers such as PVC, polychloroethene. Give the IUPAC name for phthalic acid. So here's our phthalic acid. We have two carboxyl groups on the first and the second carbon. On our benzene, so it has to be 1, 2, benzene, dicarboxylic acid. And you can't write dioic because whenever you have a benzene it's always going to be dicarboxylic for some reason. It just doesn't have the mark scheme. So 1, 2, benzene dicarboxylic acid. Part B is asking to draw the displayed formula of the repeating unit of polychloroethene. So it's ethene and its repeating unit, so we have 2 carbons and then the double bond basically becomes trailing like that. That's how I imagine it. And then there's a chloro, so we have our hydrogens, and then chlorine, another hydrogen, and I usually put the bracket around it. And a note regarding the N, basically the N is there when you've got more than one repeating unit, so it represents N number of repeating units. So the mark scheme usually says ignore the brackets and the N, but usually I don't write the N because it's only asking for a repeating unit, so that is 1 repeating unit. The ester diethyl phthalate (DEP) is used in food packaging and in cosmetics. Complete the following reaction showing the formation of DEP from phthalic anhydride. So we have an acid anhydride and it's being turned into an ester during this reaction, so we should know that an acid anhydride plus an alcohol gives us an ester. And we have 2 carbons, so our alcohol needs to have also 2 carbons. So we're going to write ethanol. So I'm going to write it like this: CH3CH2OH. And we need 2 moles of it because we've got 2 lots of ester here. CH3CH2OH. Now, the other product of this reaction takes a bit of figuring out to get to. I got this wrong first time, so this is basically how you figure it out. We have this group here. This is basically this part here. And during the reaction, this carbon and oxygen bond breaks, so we're left with just this part. Now we need to add a CH2 and a CH3 to get this product here. So we add this part here, CH2 rather, CH3, and that crosses that out, and we're left with an OH, so plus OH essentially. And then we need to consider the next part, which is this part here, and this time we're just starting with just a carbon double bond to an oxygen. We don't have the other oxygen, so we need to add another oxygen, so there, and then we need to add the carbon chain, so CH2 CH3, so that's that part gone, and we're left with a hydrogen. So this is what we're left with, 2 hydrogens and oxygen, which is water. So the next question is asking to deduce the number of peaks in the carbon-13 spectrum of DEP. So whenever you see a compound like this, look for a line of symmetry. We have one down here, that is our line of symmetry, and then count the number of carbons on one side of it. So we've got 1 there, 1 there, 1 there, 1 here, 1 here, and 1 here. So there are 1, 2, 3, 4, 5, 6 on this side, and due to the symmetry, there's going to be this carbon's going to be in the same environment as this carbon, this one's going to be in the same environment as this carbon, and so on. So there's going to be 6 peaks in the carbon-13 NMR spectrum of DEP. One of the peaks in the carbon-13 NMR spectrum of DEP is at a chemical shift of 62 parts per million. Table 3 of the datasheet can be used to identify a type of carbon responsible for this peak. Draw a circle around one carbon atom of this type in the structure below. So we're told that the chemical shift is 62 parts per million, so looking for 62, it's going to lie in between here. And looking at the type of carbon, it's a carbon with a single bond to an oxygen, so let's have a look at the carbons here. This one it can't be, this has got a double bond to the oxygen, so it must be this one. Has a single bond to the oxygen and 3 other bonds, so that's our 1 mark there. The mass spectrum of DEP DEP includes major peaks at MZ222 and MZ177. Write an equation to show the fragmentation of the molecular ion to form the fragment that causes the peak at 177. Now, this took quite a bit of thinking for me, personally, but what I essentially did was imagine that this compound here fragmented in 3 ways, hypothetically. So this benzene here would fragment, this would fragment, and this would fragment. And calculating the MZ values of each of these hypothetical fragments, I calculated that this benzene would be the C6H4 plus, because there's 2 hydrogens missing because of these 2 groups, which had an MZ of 76. And then having a look at these 2 ester groups here, each one of these had an MZ of 73. Now we're looking for an ion, fragmentation ion of MZ 177. So essentially what we could do is basically make a combination that adds up to 177. So first of all, I looked at this combination here. So imagine this. So this essentially is 76 plus 73, which is equal to 149, which is not enough. So then what I did was I started to add atoms from this part here. So I added 1 carbon, so plus 12, which gave me 161. And that still wasn't enough. I still needed 16, and conveniently we had an oxygen which has an MR of 16, so plus 16 is equal to 177. So essentially the fragment looks like this. We've got a carbon and oxygen there, and the rest of the molecule. So the equation basically is like this. So you can write DEP, but I would usually write the whole thing. I'm just going to write DEP here because I can't draw on this tablet, in brackets with our plus and free radical, and that goes into our ion, which is basically like this. So our benzene, like so, COO, CH2, CH3, and CO, and then I just drew the bracket like that, the plus what's left over here. So we have this part here, which is the free radical part, so it's our free radical sign or notation, O, CH2, CH3, and that is our fragmentation equation for this particular compound. Okay, so the last part of question 5. Because of their many uses, phthalates have been tested for possible adverse effects to humans in the environment. The European Council for Plasticizers and Intermediates is an organisation that represents the manufacturers of plasticizers. Text below is taken from a document written by the organisation. Research demonstrates that phthalates, at current and foreseeable exposure levels, do not pose a risk to human health or the environment. Experimental evidence shows that phthalates are readily biodegradable and do not persist for long in the environment. Hydrolysis of DEP in excess of water was found to follow first-order kinetics. Write a rate equation for this hydrolysis using DEP to represent this ester. Now, you need to really read this question basically. It's saying first-order kinetics, so at first you're thinking H2O and DEP in the rate order, in the rate equation, but if we have R equals K DEP H2O, if we look at our indexes, there's 1 here and 1 here, so we end up having a second order reaction. So water doesn't actually appear in the rate equation, it's just DEP, and this is something I stumped on. But obviously DEP is going to be in the rate determining step because it is hydrolysis of DEP. Even if water isn't in the rate determining step, it's probably in the following steps. So just observe that it's first order kinetics, so you can only have 1 reagent in the rate equation. The next question is basically asking is how science works question, so suggest what needs to be done so that the public can feel confident that the research is quantitative, it's reliable. And this is just one of the cases where you have to learn what the mark scheme wants. So you could write, you can investigate the products. You could write the research could be repeated. By other scientists. and over a long period of time. And you could also write results published. So again, just one of those dodgy questions where it's just worth 2 marks and you could essentially just learn the mark scheme for. But this question, again, really read the question, first order kinetics, understand what it means by first order, and you should have no problem answering this question. So that concludes question 5. Thanks for watching, and I'll see you again soon.